This is a unit circle. I've borrowed this unit circle from, well, all of trigonometry. And today we're going to look at its quirks and features, and we'll do a review of the unit circle and see all of the secrets it contains, because there are a lot of them. Let's get started. So we may or may not remember from our algebra class that the unit circle has an equation that says x squared plus y squared equals 1. So the equation for the unit circle is x squared plus y squared is equal to r squared, which in this case is 1 squared, or 1. That's going to be important later on when we start looking at relationships between our trigonometric functions. I'm going to jump get right to what we care about. If we have an angle in the first quadrant, actually, let's go back to reference angles. Sorry, I was getting ahead of myself because this is so exciting that all this stuff is showing up at once. If we want to make a reference angle for any angle going around from 0 to 360, we're going to care about its reference angle. Here's the way I describe the reference angle. The reference angle goes from the terminal side to the nearest part of the x-axis. The reference angle for any angle theta r, is the reference angle for theta. And it's the angle between the terminal side of theta to the nearest part of the x-axis. So it's measured from the terminal side of theta to the nearest x-axis. So if we're in the first or fourth quadrants, we're going to want to go to the positive x-axis. If we're in the second or third quadrants, we're going to go towards the negative x-axis, the nearest part of the x-axis. And I'm going to call that theta r. So if I have a theta, let's say theta is 45 degrees, then theta r is also 45 degrees. So if theta is 45 degrees, then the reference angle is 45 degrees. 45 degrees is in the first quadrant, so we drop down to the nearest x-axis, and that is where we find our reference angle. In the first quadrant, theta r is just equal to theta. So in quadrant 1, theta r is equal to theta. So let's put an angle in the second quadrant. And I'm going to draw an angle, random angle. That's totally just chosen at random. It's supposed to be the same. So here, if we have theta is equal to 135 degrees, to find the reference angle, I go from the terminal side of theta to the nearest part of the x-axis, which in this case is going to be the negative x-axis. Now we know that going around here is we have 0 degrees. Up at the top, we're at 90 degrees. At this side, at the far end, at -1, 0, our angle is 180 degrees. And down here at the bottom at 0, -1, our angle is 270 degrees. So if it's 135 and we look and we have to get all the way down to, and we're measuring the angle from the terminal side of 135 to the negative x-axis, That's going to leave us 45 degrees for our reference angle. So in the second quadrant, we can see that theta r is just going to be 101, excuse me, theta r is going to be 180 minus theta. So in Q2, theta r is 180 minus theta. In this case, 180 minus 135 is 45. So we would say that 135 degrees has a 45-degree reference angle. And we're going to keep going around the circle to the two that I asked you to think about. If I put in a 225-degree angle, the reference angle will go from the terminal side of our 225-degree angle to the nearest part of the x-axis. And that's going to be a 45-degree reference angle. So in this case, we have to go back to the 180. We want to see how far past 180 have we gone. And so in the chat, that is correct. In Q3, theta r is theta minus 180. In Q3, theta r is theta minus 180. Because in Q3, we're asking how far past the negative axis, negative x-axis have we gone? In Q2, we're asking how far is it to get to the negative x-axis? And then finally in Q4, I'm going to draw another 45-degree reference angle in Q4. So it's going to go straight through. So here an angle is going to be, I'm going to use 315 because that's a 45-degree reference angle in Q4. So theta is 300. If theta is 315 degrees, we want to go from the terminal side of the 315 to the positive x-axis. There's 45 degrees to go. So in Q4, how does it look? How do we figure out theta r? How do we find the reference angle in the fourth quadrant? We know that this 0 is also a 360. So we want to figure out how far is it to keep going to get to the positive x-axis. So we'll do like we did in quadrant 2. We'll do 360 minus theta. Because we will need to continue going on that positive direction to get to the positive x-axis. So since we have to subtract 360 minus how far we've gone, that's what we have left to go. Just like in quadrant 2, how far is it to the negative x-axis? We've gone 135. If we subtract 180 minus 135, that's going to be how far we have to go. When theta is 225, we want to ask how far past the negative x-axis have we gone? So we're going to do 225 where we're at and subtract the 180 to find out the difference in how far we've gone extra. Any questions? All right. So let's take a minute, and that's going to take more than a minute. Let's look at let's identify the 30, 45, and 60-degree reference angles in the first, second, third, and fourth quadrants. So that's going to be our next thing. Now that we've talked about how to find reference angles in a given quadrant, let's take the common angles and look at those reference angles in each of the 4 quadrants. So I'm just going to have another big circle. break out my circle machine. This is my cool circle machine. It like twists like this. It's a little copy of the Stargate, although I can only send very small things to different Stargates. I also have a way to find the center. Always very important to be able to find your center, not just in math, but also in life. Right. So I know it's terrible. I'm using a pen on this, but there we go. This also doubles as a little stand, so you can stand up like a little Stargate on your desk. All right, so now that I have, let's look at this other unit circle. Make another copy of it. So stage one, how do we figure out a reference angle for a given angle based on the quadrant in which it sits? Now let's look at the 30, 45, and 60 degree angles. Let's look at angles with 30, 45, and 60 degree reference angles. So we know that we've already got halfway up. Here are all our 45 degree reference angles. So we know that if theta is 45 degrees, then our reference angle is 45 degrees. And if theta is 315 degrees, we'll have a 45 degree reference angle. And if theta is 225, we want to associate 225 with 45 degree reference angle. And if theta is 135, those are all our 45 degree reference angles. 45, 135, 225, and 315 all have 45 degree reference angles. So let's look at the other angles. The other angles that are important. Is important the right word? Maybe. We also want to look at, let's say, 60 degree angles. Maybe a little past the 45. If you just continue the line straight through, that'll give you a 60 degree reference angle in the third quadrant. So if I have a 60 degree reference angle in the first quadrant, that's just going to be 60 degrees. If I have a 60 degree reference angle in the third quadrant, knowing that, let's see, here we start off at 0 degrees, here we up to 90 degrees, here we're at 180 degrees, and here we're at 270 degrees. So what's the angle, what's theta if we have a reference angle of 60 degrees in the third quadrant? So here's 180. If we go 60 past 180, where are we at? 210 is only 30 past 180. That's going to be coming up. So 180 and then go 60 more. So 240 will give us a 60 degree reference angle in the third quadrant. So 60 and 240 are now related with that 60 degree reference angle. Let's put a 60 degree angle, 60 degree reference angle in the second quadrant. So if we go straight through the origin, that'll give us the same on both sides. And if we use the same y coordinate, that'll give us the same angle. So all these blue angles have a 60-degree reference angle. So what is theta if we are 60 degrees before the negative x-axis? So that'll be 120 up here, 60, that'll add up to 180. So 120 is now also a 60-degree angle. Those two are associated. We know that 0 degrees is the same location as 360 degrees. So we can also figure out a theta with a 60-degree reference angle in the fourth quadrant, and that'll be 300 degrees. So your 60-degree reference angles are 60, 120, 240, and 300. And so finally, let's take a look at our 30-degree reference angles. So a 30-degree reference angle in the first quadrant is just going to be a 30-degree angle because they're the same. Drawing this straight through, we have a 30-degree reference angle in the third quadrant. That'll be 30 degrees past 180, so that'll be 210. I can dig that. I don't know why I kept writing theta. It was kind of, oh well. I've started doing it now. I have to keep doing it forever. So then I'm going to go for the second and the fourth quadrants. Kind of missed. So here in orange, we're still going for a 30-degree reference angle. What's 30 degrees before the 180? 30 degrees before 180 is 150. And then 30 more degrees will get us to 180. And what's 30 degrees before the 360? 330. So here are angles between 0 and 360 that we should recognize. We have the angles with 30-degree reference angles: 30, 150, 210, and 330. Angles with a 45-degree reference angle: 45, 135, 225, 315. Angles with a 60-degree reference angle: 60, 120, 240, and 300. So in those groups of 4, we want all those organized. I do not know which way of putting all these things together is going to work best for you. This picture really sits in my mind, and so this is how I make those associations. This is how I associate 30, 150, 210, and 330, 45, 135, 225, 315, 60, 120, 240, 300. I've associated all those. They're not all the same, but they all have the same reference angle. That's grouping these angles by reference angle. So if we think about a 30-degree, the other way might be to make a table, say our reference angle of 30 degrees, 45 degrees, and 60 degrees. And each of these reference angles has representation in the 4 quadrants. So it might be, so we have quadrant 1. Our 30-degree reference angle is just 30 degrees. In quadrant 2, a 30-degree reference angle is 150. In quadrant 3, a 30-degree reference angle is 210. And in quadrant 4, a 30-degree reference angle is 330. So 30, 150, 210, and 330 are all associated by a 30-degree reference angle. The 45-degree reference angles in each of the 4 quadrants. In quadrant 1, it's just 45 because it's always the same. In quadrant 2, it's 135. In quadrant 3, 45 degrees is 225. And in quadrant 4, 45 degrees is 315. And finally, associating by 60-degree reference angles, we have 60 degrees in quadrant 1, 120 degrees in quadrant 2, 240 degrees in quadrant 3, and 300 degrees in quadrant 4. You want to associate all these values. You want to look at 150, 210, and 330 and say that's a 30-degree reference angle. You want to look at 135, 225, and 315 as 45-degree reference angle. And you want to remember 120, 240, and 300 are all 60-degree reference angles. You need to associate these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 angles with their reference angle and their quadrant. So if I say, what's the reference angle in quadrant for 315? You say it's 45 degrees and it's in the 4th quadrant. What's the reference angle and quadrant for 120? You would say it's a 60-degree reference angle in quadrant 2. We could use these as kind of a launching pad for things that are in between. So if 150 is a if 150 is a 30-degree reference angle in quadrant 2, if I bump that up to 160, that'll be a 20-degree reference angle in quadrant 2. That might be a useful way to look at it too. I think the least useful way to remember these values is to sit down and memorize formulas. Anytime you can eliminate formulas from your life, you should eliminate formulas from your life. It's useful to see how things are put together, but more important, it's less about looking at theta r equals theta minus 180 for quadrant 3 and remembering that, and more important to recognize what this is telling us. How far past 180 are we? What's the difference between where we are and where we were at 180 degrees? Just like theta r is 180 minus theta, how far do we have to go to get to 180? Because we know we're in the 2nd quadrant. So don't memorize formulas, make associations, but don't memorize the table, just remember. Don't memorize the unit circle, just remember. Any questions? How's everybody okay? Page 2. All right, so that's stage 2. Identifying how we figure out reference angles, not the formulas, but the process. Learning the common reference angles in each of the 4 quadrants. I didn't put the bow tie for the 45s. This is a bow tie technique. It's also like a Star Wars targeting thing. A little TIE fighter. Beep, 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 beep. You know what I'm talking about? Have you seen Star Wars? It's this movie. There's a war among the stars. You may have heard of it. So we got to remember this, and we also got to remember some exact values of sine, cosine, and tangent. So now that we've learned, we haven't memorized, we just remember, we know sine, cosine, and tangent of 30, 45, and 60. Now we want to learn sine, cosine, and tangent of all 12 of these. So we want to combine. Now we combine trig function trig values of 30, 45, and 60 with quadrant information. That will help us get the trig values exact. We're going to combine our knowledge of exact trig values of 30, 45, and 60 with quadrant information, and then we'll have exact trig values of all 12 of these angles. Now we're going to combine what we know. We know the exact trig values for 30, 45, and 60. We're going to combine that with quadrant information to get the exact trig values of all 12 of these angles. So let's do that. First, I'm going to talk about just how it works. So we're going to have some trig value of an angle. So trig function of some angle. So this trig is going to be sine, cosine, or tangent. And our angle is going to be the one of the 12 with a 30, 45, or 60 degree reference angle. And we need to get two things: a sign, positive or negative, so S-I-G-N. We're going to fill in two boxes: a sign and then a value. And this will be the 1/2 root 1 over 2, root 2 over 2, root 3 over 2, or 1 over root 3, a 1, or a square root of 3. The value is going to come from the trig combination of the trig function and the reference angle. So the value itself is based on the trig function and the reference angle. So value is based on the trig function and the reference angle. The sign is based on the trig function and the quadrant. So the sign is based on the trig function and the quadrant. The value is based on the trig function and the reference angle. So let's see how it works. There's one more piece of information that we need. We need to figure out how to decide on the sign based on the trig function and the quadrant. To do this, there's no trick to it. It's just a simple trick. We're just going to try to remember what's positive where. This is what I call what's positive where. In the first quadrant, all are positive. In the second quadrant, only sign is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. So this is what's positive where? In the first quadrant, all are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, only cosine is positive. So that's combining the trig function and the quadrant to get a sign positive or negative. And then we combine the trig function and the reference angle to get the value. So, for example, now these reference angles are ones that we all know. So if I, for example, said, what is the exact value? That means we're gonna have to write square roots and such of the cosine of 210. So here's how we think about the cosine of 210. First thing we notice is that 210 is in the third quadrant, and that's going to give us positive and negative. So 210 is in the third quadrant, and cosine is negative. Only tangent is positive in the third quadrant. In quadrant 3, cosine is negative. Then we get the value. 210 is a 30-degree reference angle. And the cosine of 30 degrees is √3/2. So we get the positive and negative from the quadrant and the trig function. Cosine of 210 is negative. The value we get from the reference angle. 210 is a 30-degree reference angle in quadrant 3, and the cosine of 30 degrees is √3/2. So that's where we get the value. So we just have to make two decisions, one based on the trig function and the quadrant, the other based on the trig function and the reference angle. Let's look at another example. Let's suppose that I wanted to figure out the tangent of 210. The exact value of the tangent of 210. We look at the 210 and we see that 210 is in the third quadrant, and in quadrant 3, tangent is positive. That's in my what's positive where. We'll get into why what's positive where is positive where it's positive. But I want the 8 simple tricks to crush your next trig exam. 210 still has a 30-degree reference angle. And so the value is based on the tangent of 30. Tangent of 30 is 1/√3, or √3/3, however you like to remember it. So the tangent of 210 will be positive. We don't normally write it, but I want to emphasize that's from the quadrant information, and then the value from the reference angle. And there's the exact value of the tangent of 210. Now remember, we also want to make sure that we know our decimal equivalents, because we might want to check this. So let's grab our calculator and say, hey, calculator, are we in degree mode? And the calculator's like, oh, yes, we are in degree mode. And so all right, great, calculator. What is the cosine of 210 degrees? And it's like, negative 0.8660, which we recognize as the square root of 3/2. So we got the sign right with the negative. 0.8660 is our calculator's way of saying √3/2. And we can check with tangent of 210. It's positive 0.5773, which we know is 1/√3, or √3/3. So that's how we can check. Knowing the decimal equivalents will help us quickly check if we got the right values on our calculating machines. Any questions? All right, so you have much to do. I want you to be able to identify the sine, cosine, and tangent of all these angles with 30, 45, and 60-degree reference angles. Fortunately for y'all, you have until Wednesday to do it because we got a 4-day weekend coming up. And those really, really crush the number of meetings on these Monday, Wednesday classes. Any questions, comments, deep thoughts? So these values, these are going to be in the homework. So there's a lot of, the homework has all been assigned for chapter 2. And then I'll put up another quiz, and the new quiz is going to be know your values. So there's going to be a new quiz where you have to remember your sine, cosine, and tangent of 30, 45, and 60. And then there's going to be another quiz, know your values part 2, where you have to combine your quadrant information with the trig functions. So this quiz is going to be set up differently. It's going to be multiple choice. And since it's going to be multiple choice, you're going to have a limited number of responses. So there's going to be, you're going to have 3 chances to get it right. But I mean, if I gave you unlimited tries, then you could just keep going until you get it right. So I'm only going to give you a limited number of tries on these quizzes, the know your values quizzes. Any other questions? All right, that's it for this week. I will see y'all next week on Wednesday. It could be more, it's going to be more than one quiz that shows up, and it's all going to be know your values, multiple choice, limited chances to succeed. So make sure you know your values. That's it for this week. Everybody have a nice weekend. I'll see y'all on Wednesday, and thanks for playing.